Let's welcome David Chappell, principal at Chappell & Associates. David will show us how the move to a devices and services world, it affects end users, independent software vendors, and system integrators.
Thank you. Thank you very much. Good morning. It's such a pleasure to be here today. I have been to Romania a number of times, but I haven't been here for 4 or 5 years. It's great to be back. It's great to be back. You know, I travel a lot. It's the nature of what I do. I was in Vienna not too long ago, where I gave the opening keynote for a day of events at which the closing keynote was given by Bill Gates. And because I did the opening keynote, they asked me to introduce Bill at the end. And I said, sure. So before Bill's keynote, I go backstage, I meet Bill, and we talk about how the intro is going to go. Bill says, when David introduces me, as I go on stage, should I shake David's hand? That's the usual thing, to shake hands at these big events. But the organizer of the event says, no, Bill, don't shake David's hand, keep it simple. And Bill said, okay, and I said, okay, and I walk on stage. It's an enormous room. 1,000 people and the entire Austrian press corps are there to hear Bill. I walk on stage, and I get the warmest applause of my entire life because for just a minute they think I'm Bill. It was so great. Rock star for a minute. They realize I'm not Bill, they stop clapping. Okay. I do my intro. Ladies and gentlemen, Bill Gates. And Bill starts walking on, I start walking off. It's an enormous stage. The stage is bigger than this room. It's huge. I'm walking off. Bill's walking toward me. As Bill walks toward me, what does he do? He raises his hand. I'm thinking, we agreed not to do this. But if Bill Gates wants to shake my hand, I will shake his hand. So I raise my hand, and I'm walking. And just as I raise my hand, I look in Bill's eyes, and I can see him remember, oh, wait, we agreed not to do this. So just as I raise my hand, Bill drops his hand. And I drop my hand, and I slink by, having just been snubbed by Bill Gates in front of 1,000 people and the entire Austrian press corps. This is a true story. Why did this happen? It happened because somebody asked Bill to change. The change was small, don't shake hands. And Bill's a pretty smart guy, yeah? But he got it wrong. Why? Because change is hard. Change is hard. I ask you, however, in our profession, in our world, what is it that we are asked to do every year, every month, every week, every day, it sometimes feels like? Change. I'm here this morning to talk about the transformation of IT. The big idea is simple, but critically important. The big idea is this: the IT world is changing fast. We must also change. There are lots of ways to think about that change. Here's the approach I want to take. We can think about our world in 3 big buckets. Bucket number 1 is infrastructure. The servers, the VMs, the things in which we run applications. Bucket number 2 is those applications. Bucket number 3 is the data the applications use. I'm going to talk about change in all 3 of these areas. Before I do, however, let's just review where we are today. Today, as you all know, infrastructure is mostly about servers and VMs. We run our apps, we access data from VMs running in physical servers. Great. We also build applications mostly in the traditional way. Maybe a .NET server running on Windows Server, a web client or a native Windows client, classic model. And for data, we of course use relational databases, the standard for, decades now. That's the world we live in today, right? Look familiar? Here's the thing. Every single one of those 3 areas is changing in important ways right now. For example, infrastructure is moving from just VMs and servers to include private clouds and public clouds. Applications are changing in deeply important ways. We're seeing the rise of software as a service, SaaS applications that run in the cloud, and we're also critically seeing the rise of devices and mobile apps. And for data, relational databases still are important, obviously, but we see the rise of big data as well, which is often, not always, non-relational. The key point is this. The key point is changes are happening simultaneously in all three of those areas. This is a big deal. It's a big deal. And you know, you can argue that those changes across all three of the spaces that we work in are actually driven by the four megatrends we've been hearing about, by cloud, by mobility, by social, by big data. So, I'm going to discuss those three areas, look at those changes, see what they mean for you, and in each area I will discuss how the megatrends apply. Let's start. Infrastructure, the foundation of everything we do. I'm going to argue that the most important technology in infrastructure right now, this is kind of an odd argument, but bear with me, is something called Infrastructure as a Service, IaaS, commonly pronounced IaaS, at least by Americans. What do you say in Romania? Do you say IaaS? No? Okay, well, I'm going to say IaaS because I'm an American. Okay. The idea is incredibly simple. Today, if somebody, a developer say, wants a new virtual machine, what do? They go ask somebody for it, and that person creates it. IaaS just means the automation of this process. So now, our user who wants a VM has access to a self-service portal. That's a fancy term for a website. It means a website, okay? And through this portal, she can look at a database of VM images. And she can choose one. She can say, I would like, please, a VM with 4 cores running Windows Server 2012 R2. She asks for it, and it's created for her on some server. This is IaaS. IaaS means self-service VMs on demand running on pooled hardware. Okay? Why is IaaS so important? Because IaaS underlies, it's one of the core technologies underlying the big megatrend of cloud. If I do IaaS in my own data center, people call the result a private cloud. Now, not just IaaS. Private clouds are more than just IaaS, but IaaS is, for most people, the defining technology of private cloud. If I do IaaS in an external data center, we call the result a public cloud. Great. They're both called clouds because they both do IaaS, VMs on demand running on pooled hardware. And this similarity has led people into deep confusion. Because I cannot tell you how many times I've been asked, David, should I use a public cloud or a private cloud? As if they're somehow interchangeable. But they're not. Please don't be confused. Even though they're both called clouds, even though they're both rooted in the same technology, IaaS, the truth is they provide really different benefits. You want a private cloud because it helps you make your data center more efficient, more effective. Private clouds make your on-premises world better. You want public clouds because they give you access to massive scale data centers with pay-as-you-go pricing. These are totally different things. You probably want both, but for different reasons. Don't be confused by this. Never think that private clouds somehow are a substitute for public. They're not. They're different. They're both useful, both interesting, but not the same at all. You know, here's the truth. The truth is that if I ruled the world, I would find the person, I would hunt down the person who coined the term private cloud, and I would shoot them. Because I think that word is so confusing. I don't rule the world, obviously. If I ruled the world, I would have hair, but not an option. Let's talk for just a minute here about private and public clouds. Why would anybody want to use a private cloud? Well, VMs on demand, IaaS. That's a nice thing. But private clouds, as I said, can be a lot more than that. You can deploy not just VMs, but full applications. You can even automate things like detecting and recovering from problems of your applications and more. In the Microsoft world, the technology for this is the 2012 release of System Center. Public clouds also have value, as I said, but they're very different. What they bring to the party, the reason you'd want them, is very different from private clouds. Here you can again get VMs on demand, IaaS, but now they're running someplace else, and you're paying for them by the hour, and they're cheap. You can also use public clouds to let developers have an environment for building dev test worlds in those VMs. It's a common thing to do. You can deploy applications, packages like SharePoint, custom apps. You can use storage, because these massive cloud data centers have very cheap storage, and a lot more. In the Microsoft world, the technology here is Windows Azure. And if you're interested in either of these, I'm doing sessions later on today that talk more about these cloud topics. But, turns out that when people look at public cloud technologies like Windows Azure, they very commonly start in the same places. People almost always start using public clouds with one or both of two scenarios: VMs for dev and test, or storage, simple storage. Why? Why? The reason is that those scenarios are pretty simple and easy to do, and they provide immediate value, but also, this is important, those scenarios let people get their feet wet and deal with what are the most common, most substantial objections to using public clouds. Let's talk about those. I've done a whole lot of talks on public cloud technology in a lot of countries. Every single talk, every single country. Question number one is always some version of this: can a public cloud really keep my data and my applications safe? In fact, that's the polite version of the question. More often people will say, David, are you out of your frickin' mind? Do you really think I'm going to put my data in some Windows Azure data center in Dublin or Amsterdam? Are you out of your mind? People look at this and think about security, because you are accustomed to worrying about security. You worry about whether your firewall settings are correct, keep out those attackers, because it's your job in your data center, some of you. With public cloud platforms, these kinds of things no longer become your responsibility. You can't control them. Microsoft, no other public cloud platform provider, will let you go to their data centers and check the firewall settings. You can't do it. Instead, what has to happen is we have to learn to trust our public cloud providers. It's about trust. How do we build trust? You know the answer. Usually, we build trust slowly. You start small. You take small risks, get benefits, grow from there. That's why, with Windows Azure, the most common scenarios to start with are the ones I showed you. They're low risk. Get your feet wet. Build trust. I believe that we are seeing this trust be built right now around the world. People use public cloud technologies more and more. Simple things like SkyDrive or Dropbox. Email in the cloud. In businesses, email is going to the cloud very rapidly. For personal email, it's all in the cloud. We are seeing this trust get built over time. So I believe that we are seeing what we've seen many times before, the growth of trust in a new technology. I believe this will not be a serious problem in just a few years. Although, I gotta say this. People are irrational about trust. I'll meet with the CIO who says to me, David, I would never use any of this stuff for my enterprise technology. I've never trust the cloud. And then he sends me documents via SkyDrive, which runs in the cloud, right? It's mystifying. Or here's my favorite example. Ask yourself this question. What is the world's scariest technology? Is the world's scariest technology nuclear weapons? Is the world's scariest technology, I don't know, some dangerous computer virus? No. No. The world's scariest technology is Windows Update. Let me tell you why. Let me tell you why. It's because every Patch Tuesday, Microsoft puts in your operating system whatever code it wants. And we trust them. Now, maybe we test to make sure it doesn't break anything, but nobody tests that code to make sure it's not stealing all your corporate data. We trust them. Imagine that tonight it was announced that the entire corporation of Microsoft was purchased by the government of North Korea. Unlikely, I know. But suppose that happened. You would all turn off Windows Update, wouldn't you? I hope so. I would. I wouldn't trust them. My point here is twofold. Number one, we are irrational about trust. Number two, the trust we already have in vendors like Microsoft far exceeds what technologies like public cloud platforms ask of us. We already trust these people so deeply. This is not, in fact, a big step forward. Question number two, though, is always this. If you say, okay, I trust, but now what? What about this? There are laws, regulations about data in the public cloud. Can I still meet those requirements? The answer here, sadly, is more complex. You have to understand the rules that apply to you, and this can be hard sometimes. Because the laws and regulations covering off-premises computing vary across vertical markets, financial services, healthcare, government, whatever, and they vary across countries, Romania, US, whatever. The result is a matrix of laws and regulations. I would submit to you that no one in the entire world understands that matrix. I would go even further. Probably no one in the entire world really understands even any single cell of that matrix. Why? Because those laws and regulations were largely designed for an era before cloud computing. And so whether you comply depends on the opinions of auditors, or worse yet, lawyers. So what happens? What I find is that when people look into this, usually they find they can do more than they thought they could. I met with an IT leader from a French bank in Paris a while ago, who told me his bank had done a detailed survey of all the French regulations against all their data. What they found was that 90% of their data could legally go in the public cloud. Surprising. I hear that story a lot. So don't be stopped by these, but take them seriously. Almost done with this section. A couple more big points. I said earlier that public and private clouds do different things, provide different benefits. Therefore, you probably want both of them. If you want both, that means that how well they work together is really important. In the Microsoft world, that connection is made largely through the 2012 release of System Center, which can of course be used to manage private clouds, but also to move VMs around, manage, automate Windows Azure public clouds. Again, if you care about this, I'll discuss this more later on today in one of my sessions. One more important aspect of how things work together on premises and public cloud is identity. Identity. We'd like single sign-on, wouldn't we? So today, what do? Today, everyone, practically, runs Active Directory. Users log into AD, can then access applications running locally in the private cloud or elsewhere without a separate login. Great. With Windows Azure, there's a technology called Windows Azure Active Directory, which can connect with on-premises Windows Server AD and give users single sign-on to apps running on Azure. That's important. It makes access simpler, more straightforward for the people who rely on what we do. One more point about this, Windows Azure Active Directory is also used by Office 365. So if you use any of those services, they also connect in the same way for a unified single sign-on identity approach. Interesting. So, In this brave new world of cloud computing, what skills do you need for infrastructure? Well, it depends. If you're all about on-premises, all about private cloud, in the Microsoft world, that means you've got to work with and understand SysMinter 2012 and its follow-ons. If you're a hybrid person using both, then you'll care about managing both SysMinter 2012 and Windows Azure in the Microsoft world. And if you're pure public cloud, which almost no one is today, you care about managing Windows Azure applications. The truth is, most of you are going to be here. Most will have a hybrid world at some point of mixed private and public. So if you do infrastructure, I encourage you to prepare for that world. Next, applications. I mentioned this earlier. Traditionally, applications work like this. We have a server running in some VM or physical server and clients, web browsers, maybe they're native Windows clients, whatever, okay? That's the classic model, and that's still the best choice for some number of traditional business apps. Still the best choice. However, the world is changing. This megatrend of cloud lets us do this. It lets us, if we want to, deploy that server application on, let's say, Windows Azure. You can do that. Now, is this truly a cloud application? I don't know. It still has to scale for only one organization. It doesn't require fancy redundancy or massive scalability. You can take your classic Windows Server app, put it up on the cloud, and run it there if you want to. Great. Turns out that as an app developer, it's not really any different. It's a deployment choice. But now, think about this. The cloud megatrend also brings us a whole new approach to build applications. Because suppose I want to build a cloud application that's used by lots of organizations at once. This is the problem faced today by almost all independent software vendors, ISVs. Because going forward, the default for ISVs is SaaS. It's to build cloud-based SaaS applications that are used simultaneously by lots of customers around Romania, around Europe, around the world. If you're an enterprise developer, even some of the apps you build might need this structure. Those accessed by your customers around Romania, around Europe, around the world. This app style is really different in important ways from the conventional model of building servers on Windows. Differences include these. The app's got to be really reliable and really scalable. It's being accessed by lots of organizations, potentially, or lots of customers. The app's got to be really secure. It's running on the public internet. The app's got to be able to be modified and maintained with no downtime. You can't have maintenance windows in apps that are used by folks around the world. It doesn't work. And if you're an ISV especially, the app must be multi-tenant, which means that you have to be able to support multiple independent organizations from one code base. These are all quite different skills from the conventional world of building Windows Server apps. I'm not saying all apps should be like this, no. But a good share of apps going forward, especially ISV apps, have to be this way. New skill set. Let's go back to the conventional app model. Let's discuss another of the megatrends and see how that affects apps, the mobile megatrend. Here, a conventional Windows app running on a single server, the ordinary .NET approach that most of you are familiar with if you're a developer, it looks like that. Great, but now this mobile megatrend means that I've got to have clients that are not just PCs, not just web browsers, but their phones, their tablets. Have you heard this term, post-PC era? Have you heard this? People tell us we're living in the post-PC era. Ladies and gentlemen, this is the stupidest thing I have ever heard. Let me tell you why. I'm willing to bet that all of you in this room have a phone in your pocket, right? Probably a smartphone. I'm willing to bet that most of you have tablets. I sure do. They're useful things. They're very important things. But what is on your desktop at work? It's a monitor, right? A big monitor, maybe two big monitors, a nice fancy keyboard, a precise pointing device called a mouse. That's called a PC, people. Do you want to get rid of that? Are you going to use your mobile phone instead of that? This is just stupid. For writing software, for writing documents, for doing graphics, for editing video, for a whole range of things, we want PCs. To believe this is the post-PC era is deeply, deeply misguided. In fact, this is not the post-PC era, this is the PC Plus era. This is the PC Plus era, where certainly lots more matters than just PCs, tablets, phones, but PCs and laptops are going to matter for who knows how long, a long time to come. So please, do not talk about this as the post-PC era. It's not. It's the PC Plus era. If I combine that reality with the reality of multi-tenant or multi-user cloud applications, we're now seeing two megatrends come together. When two megatrends come together, really interesting things happen. So for example, if I've got to build an application, I'm an ISV for instance, building a SaaS application today, probably I've got to deal with both that cloud trend and the mobile trend. My customers will use probably PCs and laptops, but they'll want mobile client, telephones, tablets. This is interesting. This is really interesting. This is really the strongest expression, I would argue, of applications in a devices and services world. So, let's talk about this for a couple of minutes. Keep this picture in your head. These apps have functionality in the cloud, and they have some functionality on the device. Device here means client. Device means PC, laptop, tablet, phone. So there's some functionality in the cloud and some on the device. Let's look at that. You can graph that. You can say, okay, what percentage of the app's functionality is in the cloud, and what percentage is on the client, that is the device? There's a line here. And I would submit that in the modern devices and services world, every application falls somewhere on that line. So for example, a basic SaaS app, a basic software as a service application, might provide just a simple browser client, and so virtually all the app's functionality is in the cloud. Other end of the scale, a mobile game, a game on your phone, is purely, potentially, purely phone-based. Or the flashlight app, right? Flashlight, totally mobile, right? Most apps today, however, that fit in this devices and services category actually are somewhere else on that line. So for example, if you're a SaaS vendor today, you have a browser client probably, but as we heard earlier, you also are sure to have demand for mobile clients, phones, tablets. And so that means your functionality is split. Some mostly cloud, some on the device. Similarly, games today commonly have some cloud backend. Shared leaderboards, for example. So, when you think about modern apps in that devices and services way, it is useful to figure out where your app lies on this line. Why? Why is it useful? Well, let me show you. It's because where your app lies on that line determines a bunch of other things about what you're doing. Look at this. Most often, apps up there are business-oriented. They're SaaS apps, most often. Whereas apps with lots of mobile functionality are more likely going to be consumer-oriented. They're games, the classic examples. That's one thing. It also impacts monetization. If you're an ISV in particular, if you're selling an app that's mostly cloud-oriented, you're probably monetizing, making money, through subscriptions per user per month. If you're down on the mobile side, tilted toward that, you're more likely selling the app or advertising or doing in-app purchases for monetization. Similarly, where you live on that line determines technology choices. If your app is mostly in the cloud, then for the cloud functionality on Windows Azure, you'll want to use Windows Azure Cloud Services or virtual machines, the PaaS and IaaS technologies on Windows Azure. Why? Because those are general purpose support for all kinds of functionality. If your app is mostly cloud-oriented with mobile clients, you want to use those. If your app is mostly mobile and you want a cloud backend, well, that's the situation where Windows Azure Mobile Services is the right choice. It's designed for that situation. And one more. The technology you use to build your mobile app might well depend on where your app lives on this line. Because if what you're doing is mostly cloud-oriented, then you can probably get away with a mobile app built as a portable HTML5 application. Why? Because HTML5, the portable version, lets you do things that are pretty good across diverse clients, and it's easy to do. If your functionality is mostly in the cloud, you're okay with that. But if your functionality is on the client mostly, then you want to exploit every last bit of client functionality. You want to build a native client app. And that's, in the Windows world, Windows 8, Windows Phone. Don't be confused here. You can actually build Windows 8 apps that are native in HTML5. There's a talk on that later. Don't be confused about that. What I mean here is portable HTML5 versus the native apps. So my point here is that modern applications commonly have a split in functionality between the cloud and the device, the client. Working out where your app lives on that line, I think, is useful. It helps you decide a number of other things about the business model, about the technology you want to use. So, what skills do you need for this brave new world? That's what you want to do. If you want to keep on building traditional apps in the traditional style, you can. You can learn nothing new, or not much anyway. If you want to build modern, multi-tenant, scalable cloud apps, well, as we discussed, you must learn new things, Windows Azure-based skills and architectural skills. To build mobile apps, of course, you've got to have those skills. In the Windows world, that means Windows 8, Windows Phone 8, and for backends, Windows Azure Mobile Services. But what's the truth? You know the truth. The truth is that a large share of apps will require 2 or more of those. And so if you're a developer who wants a career going forward, I would encourage you to not lock yourself into one of those columns. I would encourage you to get a grip on at least 2 and maybe all 3, because modern apps going forward require more and more a range of those things. I have 10 minutes left for our last topic, data. So what's happened to data? Well, the mega trend is absolutely big data. Because look at this. The vertical axis is size. The horizontal axis is year and cost. Look at this. People estimate these things. In 1980, 30-odd years ago, it was this much in US dollars to store a gigabyte of data. Can you imagine? Almost $200,000 to store a gig of data. That's unthinkable, isn't it? It's astonishing. But as the decades go by, the cost drops to about 7 cents per gig today. What happens when data storage gets so much cheaper? You know the answer. We get lots more data. Lots more data. And so we have lots more relational data. Just to be clear, this is not, in fact, a linear growth. My line is flat, but my scale is logarithmic. Don't be confused by this, right? We've got lots more relational data, but critically, we have more and more and more and more and more and more and more non-relational data. When folks say big data, most often they mean non-relational. This is not exactly correct, I'll show you in a minute, but most often people are thinking about that purple triangle I have up there. We're seeing a big growth in video, in graphics, in giant log data, in GIS data, in sensor data, and here comes the 4th megatrend, in social data. Facebook, Twitter. Once again, when you combine megatrends, big things happen. So we're seeing this enormous growth in data. We've got to have ways to deal with this. What are those ways? Let's look at them. I don't know about you, but I just hate facts in isolation. I don't want facts in isolation. I want context. Give me a big picture view, then tell me the facts inside that big picture view. So here is a potential way to think about data technologies today. Here's how I think about them in the big picture way. It's a little four-quadrant diagram. The columns are operational data versus analytical data. Operational data is the read-write stuff that your apps use for transactions and so on. Analytical data is the read-only, usually, used for BI, analysis type stuff. There are then two rows. There's the classic world of relational technologies, and there's the newer world of non-relational, commonly called NoSQL technologies. So let's look at some Microsoft offerings in those four quadrants. Down here, we all know that world. Operational relational data, SQL Server in the Microsoft world, and on Windows Azure, SQL Database. Over here, we also have SQL Server, analysis services, integration services, reporting services for BI functionality. And there's something newer than that, parallel data warehouse. That's interesting. In the NoSQL transactional, operational data quadrant, we have things like Windows Azure Tables, which is a key value store on Windows Azure, and the ability to run traditional NoSQL databases like Cassandra and MongoDB in VMs on Windows Azure. I can't believe I just said that. Traditional NoSQL. How can it be old enough to have traditional technologies? But in our business, 2 years, 3 years, that's tradition. Whoa. So, finally, the upper right-hand quarter, that's the world of big data. That's the world of non-relational analytical data. The technology the whole world has embraced is Hadoop. And so Microsoft has a couple of versions of Hadoop. HDP for Windows, which runs on premises, and HD Insight, which runs on Windows Azure. Let me spend about 4 minutes and walk you very quickly through some of these technologies. We're looking at the trend of big data. 3 of these are relevant to big data. Let's talk about them. And let's start with PDW. As you might imagine, a technology whose first word is parallel is going to run across multiple machines, right? With PDW, you got some number of physical servers. Those physical servers can store relational data spread across them. You can then run a query that executes simultaneously across all those systems. You process data in parallel to speed up the processing of large amounts of data. That's why it's called parallel data warehouse. You might submit those from Excel or something else. Great. To work with large amounts of relational data in the Microsoft world, the technology is PDW. To work with large amounts of non-relational data, however, on Windows, there's an alternative. The technology is this thing called HDP for Windows. And architecturally, it is remarkably similar to PDW, doing the same kind of thing. You've got a cluster of physical servers that store on them now non-relational data, and you're running a query in a very general sense across all of them. In the Hadoop world, queries are expressed, typically, as something called a map-reduce job. And if you are truly masochistic, if you love pain, you can write those map-reduce jobs yourself, natively. Most folks don't. They use technologies like Hive and Pig, or with this Microsoft offering, Excel, to generate those things for you. So, this is all available, running on Windows, classic open source Hadoop. Do you notice this? I love the technology names the open source guys choose. Hive, that's a cool name. Pig. No Microsoft marketing guy would ever call his technology Pig, would he? Right? I like that. Clever. So these are all about the trend of big data, but I've been telling you several times that the really exciting stuff happens when these megatrends collide. And so let's end with one more megatrend collision, the collision of big data and cloud. That's what HD Insight is all about. HD Insight says, store your non-relational data excuse me, on Windows Azure blobs, process your non-relational data in parallel using Windows Azure virtual machines, and run your MapReduce job up there, submitted from the usual things, Hive, Pig, Excel, whatever. Why is that interesting? Why is the collision of the big data trend and the cloud trend interesting? It's because if I want to do Hadoop on premises, I need a cluster. I got to buy a bunch of physical servers. I got to pay for them. I got to maintain them. And that's worth doing if I have a lot of big data I want to process. But maybe you only occasionally have lots of non-relational data to process. Only occasionally. Is it worth it to you to invest all that money in a cluster of servers? Probably not. It's so expensive. But with a cloud solution, you can spin up the VMs you need when you need them, do your processing of big data for an hour, 2 hours, 5 hours, 10 hours, pay for those VMs for just those hours, and shut the whole thing down and stop paying. Combining public cloud technologies with pay-as-you-go access to VMs with Hadoop, big data, makes this technology much more accessible to smaller firms, because you need no longer buy and maintain your own server cluster. It's the combinations of megatrends that really create transformative changes in our world. So, if you are a data analyst, what skills do you need in a big data world? Depends what you do. If what you're focused on is relational big data, in the Microsoft world, you want to learn PDW. If you're focused on non-relational big data, that's a Hadoop story, either on-premises, HTTP for Windows, or in the cloud, HD Insight. If you do both, then you want to have both skills, obviously. And there's a technology called Polybase that lets you link PDW with HTTP for Windows on-prem to do queries across both of them. So in the big data world, there's a range of offerings here, a range of problems, a range of solutions, and thus potentially a range of skills that you'll want to acquire. And there it is. I want to end where I began. The IT world is changing fast. We have to change with it. Those changes span all three areas of our space: infrastructure, applications, and data. Those changes are driven by the megatrends that I have talked about: cloud, mobile, big data, social. And finally, my last thought, I want to leave you with this. I believe this with all of my heart. Your future depends on understanding this new world. Thank you.